Okay, good morning. So we go to the next chapter, which is called number theory. I will start teaching a little bit of that today, so that we are not behind the time plan. So that number theory is actually a very active branch of research in mathematics, and we are mainly studying the properties of the integers and its famous subset, the set of natural numbers. Of course, it doesn't mean that we are not dealing with the real numbers at all, but mainly the concern of number theory is studying the famous set of integers z. Okay, so which is this set of numbers. Etc. And then I will take n, the set of natural numbers starting from 1. Okay, so this is the convention that I will use. Some books starts from 0. I think your book also starts from 0. So mainly we want to study the properties of the set of integers. Okay, the first thing that we want to learn about the set of integers is the notion of divisibility, which of course is very clear and very easy concept for you by now, but we want to put it a little bit in a more formal setting. So I will start with a definition. Things seems a little bit unnecessary, so it seems that I am making things harder, but you need to trust me. We need to learn these things. Okay, then when we progress in this lesson, you will see that this will be beneficial. So definition. But before I start this definition, I want to ask yourself, you yourself actually know what the definition is. When I say 6 is divisible by 2, what does it mean? That's exactly the same thing that I want to define here for you. So you know that 6 is divisible by 2, 5 is not divisible by 2, yes? So when we say 6 is divisible by 2, but 5 is not divisible by 2, what do we mean actually? Yes?
The answer will not be a whole number.
Yes, so if I divide 6 by 2, it becomes 3. 3 is a whole number, is an integer. But if I divide 5 by 2, the answer would be 2.5, and 2.5 is not an integer, so I will say that it is not divisible. Yes? But the way that I want to define it is a little bit different. Exactly, that's the same concept. But we can also say that 6 is divisible by 2 because you can find an integer 3 so that you multiply it by 2, it becomes 6. That's the same idea, yes? So let me just repeat. 6 is divisible by 2 because 6 divided by 2 is 3, and 3 is an integer, yes? 6 divided by 2, it's 3, and 3 is an integer. Another way of saying this is 6 is equal to 2 times 3, yes? So I say that 6 is divisible by 2 because I was able to find a number from this set such that when I multiply it by 2, it becomes 6. That's exactly the same idea. It seems that I am making things harder, but this is the way this is the language of actually number theory. Is that understandable? So now I want to write the same thing as my definition. Okay? And the notion of divisibility is only for integers. So for example, I cannot say 2.5 is divisible by 0.5. Even if you divide 2.5 by 0.5, the answer becomes 5, and 5 is an integer. But the notion of divisibility is only defined for integers, yes? So whenever we talk about divisibility, automatically we are working within the set of natural integers or natural numbers. So I would say that let A and B be integers. We say that B is divisible by A if, okay, yeah, can you complete it for me? If what happens? I want you to define it in this way, not the previous one. Of course, you can say b divided by a is an integer, yes. But if I want to define it in the one that I described it here, what should I do? What should I write here? If what happens? Yes?
If a times multiplied by 2 is equal to b.
No. That 2 was a coincidence because of 6 and 3. So that was just particular numbers. So a and b, we don't know what the numbers are, yes?
So,
For example, 15, I don't know, 21 is divisible by 3. Why? Because 3 times 7 is 21, and 7 is an integer. Yes? Is that understandable or not? Yeah. So the notion is very simple. I don't know, for some reason people will start resisting about that, but this is very simple. So I say that I have two a and b. I have given you two integers, a and b, and I say that b is divisible by a. One way to say that is to say b divided by a is an integer. Yes? That is the normal way that we have used to so far. But if I want to express it in the language, instead of division, I want to use multiplication. How should I write that? If what happens? Yes?
What do you call the result of a division?
The quotient.
We say that b is divisible by a if the quotient is equal to, or if a multiplied by the quotient is equal to b.
You don't need to say quotient, yes, yes. So you say that if there exists an integer q, and that's exactly why I call it q, because that's the quotient. There exists an integer q such that what happens if I multiply a by that integer, it gives me b. Yes? That's the idea. Is that understandable for everyone? Yes or no? So for example, so this is important to understand. In a mathematical language, if I want to show that b is divisible by a, so let me write, in order to show that b is divisible by a, we write, this is the symbol that we use. We put a, we put b, and we put a vertical line between them. Okay, so be careful. This is a little bit unusual because in mathematics we usually read from left to right. But this doesn't mean a is divisible by b. This means b is divisible by a. Okay? So, whenever you see this symbol in number theory, it means that I am dealing with two integers. This is always implicit in this notation. We don't mention it. Okay? And the other thing is that the number on the right-hand side is divisible by the number on the left-hand side. Meaning what? Meaning what? Meaning you are able to find an integer so that if you multiply it on the left-hand side, it becomes equal to the right-hand side. Yes? For example, so true or false? Okay, so number one, let me just start this. So 6 is divisible by 2. Is this true or false? It's true, but you need to write why. So let me write motivate. 6 is divisible by 2, true. since 6 is equal to 2 times 3, this is not enough, and 3 belongs to the set of integers. So if I ask you why this statement is true, you need to say me that because I was able to find an integer such that when I multiply on the left hand side, it becomes the number on the right. Yes? Is that understandable? Okay, for example, number 2, minus 3 and 21. Let me write it like this. Is this a statement true or false? Yes? So it is still true. Why? Since, what can I write? The number on the right hand side is equal to the number on the left hand side multiplied by an integer. What that integer is, in this case, minus 7. Yes, it is minus 7. And minus 7 belongs to C. So number 3, for example, I can write minus 4 and minus 16. Is that also correct? Yes, so that is also true, but the reason, I want you to get used to this way of reasoning. So true, since the number on the right is equal the number on the left multiplied by what? 4, and I should complete it with, and this 4 belongs to Z. So in all these cases, the number on the left is playing the role of B. The number on the right, close to it, is playing the role of A. And the number that is different from case to case is playing the role of Q. Yes? Okay, and then for example, let me just write one more at least, number 4. So 15 is divisible by 2. Is this true or false? False. Why? Yes, because, let me write it in this way. Since the only number that when multiplied by 2 becomes 15 is 15 over 2, yes? But 15 over 2 is not an integer. But 15 over 2 is not an integer. Of course, you don't need to write so much. Immediately you can realize which one is true, which one is false. But if you want to write it in an appropriate way, you need to express it in that way. Is that understandable? So the only number that I can multiply on the left to generate 15 is 15 over 2. That's the only number. And 15 over 2, unfortunately, is not an integer, so we say that this is false. Yes? And if I want to show that B is not divisible, so I use this symbol. So this means that B is not divisible by A. So that's also good to know. Okay, so let me ask you something here. What do you think? Do you think this is true or false? Let me write 2, 5 0 is divisible by 5. Another one, let me write 5 is divisible by 0. Let me write 0 is divisible by 0. From your understanding in this way, I don't think you immediately realize I do not have any problems here, but I might have problems here and there. Yes, because this means 0 over 5. This means 5 over 0 if I want to translate in the division language, and this means 0 over 0. Yes, is that understandable if you want to understand it intuitively and immediately? So what do you think? Do you think this statement is true or false? True, okay? So because you imagine you put 0 on top and then divide it by 5, what is the answer of 0 over 5? 0, and 0 is an integer. That is the important part. 0 is an integer. But in this language, so I would say that this is true. Why is that? Since 5 is equal to 0 multiplied by what? Oh, sorry. 0 is equal to 5 multiplied by 0. Yes. And 0 belongs to 0. So that's true. So here, the number on the left and the quotient are coincidentally the same. What do you think? Is it a true statement or false statement? It's false. Why? Because if I want to write 5 on the left, I don't want to write it so long, but I just explain it. 5 on the left, I need to see, is it possible to find an integer so that when I multiply it by 0, it becomes 5? The answer is no. Because any integer multiplied by 0 is 0, and this cannot happen. Yes? So this equality cannot happen. So let me just write false. But if you want to describe, you need to write it in this way. But what about the last one? Yes? Why?
Because 0 is 0 times 0.
For example. So,
Anything else.
or anything else. So here, this is one of those exceptions that the definitions are different. So if you want to use this definition, you would say 0 over 0 is false. Yes? Because you say that 0 over 0 is not an integer. It's not defined. So be careful about that. So here, this is true in this way, in this here, by this definition. So since, for example, a 0 which is on the right is equal to the 0 which is on the left multiplied by 1. And 1 is an integer. But you could say 0 is equal to 0 times minus 2. And minus 2 is an integer. So that is also a good reason why this is true. So here, so far, if it was true, the quotient was a unique number. But here, you can choose any integer that you like, but this is still true. Yes? So is that understandable? So this is the way that you need to define divisibility in number theory. Yes?
You can also choose any real number. Right?
Yes?
What does that mean?
No. Of course, if I choose any real number, this equality is still true. But for divisibility, that number should come from the set of z. So even though you write 0 is equal, so you cannot say, for example, 0 is equal to that. Not because this is false, because the square root of 2 is not an integer. For having this, I am emphasizing that, so you see I have emphasized that this q has to be an integer. Okay? Okay, now let me write the mathematical definition of this. I want you to learn this as well. So we say that for all a and b in the set of integers, so this means for all. We say that a is, so b is divisible by a is equivalent to saying that there exists, this symbol means there exists, Q where in the set of integers such that B is equal to A times Q. So instead of writing so many words, you can actually write it in this language. So it is good to know this. This upside down A is actually called for all, and this is similar to E, but in the other direction, it is called there exists. So we say that B is divisible by A if and only if there exists an integer Q such that if I multiply that Q on the left, it will give me the number on the right. Now this is not compulsory, but I want you to, because I want to use these symbols, it is easier to write. Any questions? Okay. So let me just write an example here for you. So, example. By the way, before example, let me write a remark for you. You see, this was a little bit a strange way of reading, yes? I always get confused because I have used to the other way around of reading this. Let me write this symbol. So here, this symbol, we can read it in a lot of ways, yes? The first thing is that B is divisible by A. This is the first way to read it, but this is a little bit unusual, do you agree? Because you start with the right hand side first and then go back to the left, which is probably a little bit counterintuitive. The most famous one that I will usually use this one, I would say that A divides B. So this is more natural. I read from left to right. So if I want to read this, I read A divides B means B is divisible by A. That's the same symbol. This is the one way to read it. This is more usual way to read it. It's more natural because it goes from left to right. So when you see that, when you hear that I say A divides B, it means B is divisible by A. Yes. Another way of reading it is to say that B is a multiple of A. So I underline this A, don't get confused with this article, okay? B is a multiple of A, or we can say that A is a factor of B. Most of the time, and more than 90%, I use this phrase, yes? I say A divides B. It means B is divisible by A, okay? Okay, so let me give you an example. Any questions here? So example, and this is, by the way, that is very natural. When you write 6 is 2 times 3, 6 is a multiple of 2. 2 is a factor of 6. 6 is divisible by 2. Might be this is the only new phrase that you want to learn today, is that 2 divides 6. So when I write 2 and I write this, it is read 2 divides 6. Okay, so let me write an example here. Determine all natural numbers n such that 0 divides 2n squared minus 3n minus 7. Let me see if I have, no, minus 2. 2n squared minus 3n minus 2. Okay, so when do you think this can happen? The number on the left is zero actually. So when do you think this can happen, if it can happen actually at all? We just learned about 0. Do you remember? We had, I don't know, we had 0 on the left, a on the right. We have a on the left, 0 on the right. We have 0 on the left and on the right. We discussed about all these situations, yes? So how do you understand this problem? Yes?
It's the quadratic formula.
No, but yeah, that it would. Why? What is your reasoning to go to that state?
2n squared minus 3n minus 2 equals 0.
Why it should be 0? That's my point.
Because of the assignment.
No, because we saw that if this is not 0, if this is not a 0 number, it is not possible. Yes. Do you realize? So if you see 0 on the left, if it is going to be a true statement, there is only one way to make it true. Make the second side 0 as well. Because if the left hand side is 0 and the right hand side is not 0, for example 5, then what happens? Is it a true statement or a false statement? False statement, because of the way that I described it before. So you see that you cannot actually manipulate the left hand side. It is given 0. But on the right hand side you have a variable that you can fine tune it, okay, to make it right. Okay, how should I fine tune it? Now Jakob told me the answer actually. We have to make it equal to 0 and solve it using the quadratic formula, yes? So this means that this statement is true if and only if, by the way, when in mathematics text you see IFF, it's not a misprint. It means if and only if, yes? If and only if 2n squared minus 3n minus 2 is equal to 0. And I am asking determine all natural numbers so that this is true. So it means that I need to find all natural numbers which make this one true. So this is easy. Yes, let us solve the problem. So I use ABC formula. I don't know if you have forgotten. Let me write it here. So if you have ax squared plus bx plus c equals to 0, then I use this formula. X is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Yes? So here I will start with n because my variable is n here. It becomes minus b, which is 3, plus or minus the square root of minus 3 to power 2 is 9, minus 4 times this times that. So it becomes positive what? 16. Am I right? Yes. And then divided by 2 times this number, which is 4, and then 9 plus 16, 25. Square root of 25 is 5. And then I have two options. Either n is 2 or n is minus a half. But the second one is not acceptable because it is not a natural number. So the only number that is acceptable is this one. This does not belong to the set of natural numbers. Not acceptable. Yes? Is that understandable? Yeah, they are very, very simple actually. But actually, the problems in number theory are extremely hard problems. Yes? No, because here I have asked for natural numbers. So the reason that I want to say that this is not true is because it does not belong to the set of natural numbers. Okay, one question. If you think, if I have this situation, I give you three numbers. So you see this statement on the board. And of course, I do not always emphasize. When I don't say anything in this new topic, A, B, and C are assumed to be integers. If you see A divides B times C, do you think it is reasonable to conclude that A either divides B or C? Yes or no? Be careful about it. My question is, if by looking at this one, do you think I can conclude that A divides B? By the way, let me just again read it in a normal way. BC is divisible by A. Do you think I can guarantee that either B is divisible by A or C is divisible by A? Do you think that this is reasonable? And let me answer this question for this one. So if you say that this is true, for example, let us concentrate on the first one. If you say this implication is true, you have to prove it. And if you want to say, no, it is false, you need to provide me with an example that shows it is false. And I told you several times, these kinds of examples are called counterexamples. So this counterexample is a terminology in mathematics. It means that you provide an example which shows some general statement is not true. Okay, now, which one do you think? Should we go towards proving this because this is a true statement, or should we go towards refuting it because it's a false statement? Let us concentrate on the first one. Yes?
Isn't the first one true?
Okay, so how many of you agree that this is true?
False.
False. What about you? Dimitri? False or true?
I have a counterexample.
No, but let me just see how Dimitri thinks. False or true, you said? Pardon?
True.
True. So we have two. Okay, but now let us hear. Yes, Jonathan?
It's false.
It's false. So, Jakub, you have a counterexample?
Yes.
Yes? The simplest possible.
Zero.
Pardon?
If A is 0, then B times C, one of them could be 0.
Yes?
But, like, both of them don't have to be, which means that A might not be divisible by B,
Yeah.
A might not be divisible by C,
Yeah.
which means that both of them might not be true.
Okay. Yeah, but yeah, I'm not saying that this is wrong. I understood what you said, but we can cook up a better example, understandable. We don't need to work with those limitations about 0. We can have a more tangible counterexample. Yes, Jonathan?
3 times 10 is divisible by 15.
15.
Divided by 15.
Yes.
Yes.
And?
Well, they're all integers.
Okay. No, but when you want to describe, I understand your example is correct, but you need to defend yourself. Yes? So you just wrote this example and then left the other parts on me. So you should be finalize the problem. Yes, that's my point. Yes, you are right. Yes. So let me just write my example, which is probably easier. Yes. So you see, do you agree with this statement? Yes or no? Why? Because 2 times 3 is how much? 6. Is 6 divisible by 6? So it is true. This is true, but both 6 divides 2 and 6 divides 3 are false. Yes, is that understandable? So you see that, and that was more or less the example that you wanted to try to cook up, and you tried it with 15 and 3 times 10. That's also correct. So you write 15, 3 times 10, it's correct, because 3 times 10 is 30. 30 is divisible by 15, but 15, 3 is not divisible by 15. 10 is also not divisible by 15. So this is extremely important. This is a simple. I want you to understand, do not invent your own rules in number theory unless you have a good reason why they are working. And of course, it was not hard to understand because this symbol means somehow BC over A. Yes? In this language, you probably are more familiar. Little by little, you will also learn this language. So, if BC is divisible by A, you will realize that there is no guarantee that either one of them should be divisible by A. So that is the same thing. So this is true, but both of these are false. So let me write, is true, but both this and that are false. So if you tell me that from here I can conclude either one of them is true, you see it is not working because both of them are false in this case. Okay, I want to ask you the same question for the second statement, but this time be more careful. Do you think that we can prove it? If yes, you have to prove it. If not, you need to bring a counterexample to show that this is in general not true. Yes, Jonathan?
It's not true.
Yeah?
For example,
Can you speak louder, please?
3 is divisible by 1 plus 2,
Hmm?
but 1 is not divisible by 3, and 2 is not divisible by 3.
No, you are confused yourself with the direction of reading. So let me tell you, which one do you want to write as A?
3,
Okay, and then
1 and 2.
1 and 2, yes. So this is true. Everyone agrees because 1 plus 2 is 3 and 3 is divisible by 3. So this is a true statement, but both what? 3 divides 1 and 3 divides 2 are false. Yes? So be careful. You are not allowed to conclude this in this direction. So both of them are false. By the way, in mathematics, when we say a statement is false, it doesn't necessarily mean that all the time it is false. It means that you can find a counterexample. Even one is enough. For example, I can cook up hundreds of examples that this work. Yes? For example, if I take, I don't know, 2 and then I write 4 times 6. Do you agree that this is a true statement? Yes. Can I conclude that 2 divides 4 and 2? So you see here, this is true, this is also true, this is also true. Yes? So I can cook up a lot of examples so that this will work, but I cannot rely on that as a general statement. That's the whole point. When you say something in mathematics is false, it means there exists a counterexample. Yes? Okay. Now let me ask you one more question here. So this is very important to realize just in the beginning. So I give you 4 real, let us make it natural, okay? A, B, C, and D belongs to set of N. And I tell you that A times B is equal to C times D. Okay, so let us write some statements. So assume that this is given and this is true. Assumed to be true. Assumed to be true. Do I know these numbers individually? No. But I know whatever they are, A times B is equal to C times D. Yes, I am assuming that this is true. Do you think, can I conclude that A is equal to C, B is equal to D? Or A is equal to D, and b is equal to c. Do you think from here, can I conclude this? So when you say no, you need to provide a counterexample, and the counterexample shouldn't be that hard. Yes? Yes, someone? Yeah, Amanda, just this one, yeah.
Okay, for example, 3 times 8 is 24. And then
Let me 3 times
8
is
24.
Oh,
Then that's equal to 6 times 4.
yes.
And then
Yes, but none of them is true. Yes?
Yeah.
3 times 8 to 24, 6 times 4 is also 24. So this statement is true, but neither this one is equal to that one. This one is none of them are equal. Yes? So you cannot conclude. So be careful. If you have this in number theory, so you shouldn't be in hurry saying that okay, either this one is equal with this one or it is equal with the second one. No, because you see in this example this is not true. But let me ask you this. Do you think that I can conclude that A divides CD? So this was false. What do you think here? True or false? Yes?
Is it true?
Is it? Yeah, it is true. Why?
Because B is equal to C divided by A if you use the formula.
Yes, and then? You should, yes, then?
And B belongs to...
Yeah, that is important. That last statement is very, very important because whenever you divide, you get something. That is for sure. If you divide a number, for example, if I divide 3 by 2, definitely I get 1.5. I will get a number. But the whole point is that that number should be an integer so that I can conclude that this is true. Yes? So this statement is true. If you see this and if you want to, you can conclude this. Why? Because the right-hand side is a multiple of the left-hand side. What is that multiple here? Is b. And b is a natural number, which automatically means is an integer. Yes? So this is true. What do you think about this? Can I also conclude this? Yes, that is the same thing. So this is true. That's also true. Okay. Okay, so let me, yes?
Is it important to say that B belongs to the set of integers and not to the set of natural numbers?
Yeah, probably that's also correct. But the reason when I say it is in integer, no, so you cannot fight with the problem. The problem has given you that this is in n.
Yeah.
But when something is in n, automatically it is also in the set of natural integers. Yes. Okay, now let me try to... There are some rules that you can always be sure about them. So, let me ask you, E belongs to Z, okay? Can I conclude that A divides itself? Yes or no? Yeah, this is true, yes? Even in the case A is 0, that is still true. Yes, because if A is 0, do you remember we had this before? We showed that this is actually true. So if A is an integer, if you want to, you can immediately conclude that this is the case. Okay? So I don't know, if A belongs to Z, can I conclude that 1 divides A? So it means immediately in mind, A divided by A is an integer, yes? Because it is A itself. So that is also true, yes? What about minus 1? Yes? So immediately, you should convince yourself more or less immediately. Take any integer number and then in your head divide it by minus 1. Will be the answer an integer again? The answer is yes. So that's also true. Even if A is equal to 0 in this case. Okay, another story. So if A belongs to Z, and m and n belongs to the set of natural numbers. Okay, let me ask you something. Can I immediately conclude that mth power of a divides the nth power of a or not? I need to add something to make it right. Yes? So I want to add something here so that I can conclude that this is true. Yes, Jonathan? Yes. Greater than or equal. Yes? So this is extremely important. And m is less than or equal to n. Yes? Then I can conclude a to the power of m divides a to the power of n. Is that understandable for everyone? Because, for example, first of all, tell me why here I have emphasized that m and n should be a natural number, not the set of not an integer in general. Yes. If it is negative, I will have problems here. Yes, because, for example, if I choose a to be 2 and if I choose m to be -3, then 2 to the power of -3, even though it is composed of integers, but the answer is no longer an integer. And I am not allowed to use this symbol unless both of them are integers. So this is a have to. I have to make this right so that this is sensible. But I also have to have m less than or equal to n. Okay? Can you tell me what would be the quotient in this division? Yes?
M minus a to the power of n minus n.
N minus n.
N minus m. Yes, because you divide the right-hand side by the left-hand
Oh,
side.
yeah.
So that is also clear. So these are the things that you can discover when you need. So I cannot write all of them, but you need to really convince yourself that they are true and use them. So you might felt that this was also right, but you see that this was not right at all. Yes? For example, can you, let me just test your understanding again as an example. I want to write this properly. So let me just repeat this one for you. So we had this statement and we'll realize that this is not true. Okay? Now let me change the direction. Okay, can you tell me what can I conclude if I can conclude something? I want you to write two statements here so that it is true. The reason that you are actually thinking a little bit hard because this direction is actually a little bit unfortunate. You need to get used to reading it the other way around. This means that I want to make A divisible by the product of BC. If A is divisible by the product of BC, what do you think I can conclude? Yes, Dima? And. Yes, it is divisible by both of them. Hopefully it's understandable, yes? So here I can say that B, A is divisible by B, B divides A, and C divides A. Yes? Is that understandable? So it means that I write A in the numerator, I write BC in the denominator, and I know that the result is an integer. Why? Because you are telling me that BC divides A. If the result here is an integer, do you agree that, for example, A B over B should be also an integer? Yes? Because if that is not an integer, so if A is divisible by B, by the way, is that right or not? Yes, the answer is completely right, but if I want to, let me prove it, okay? So this is true. Let us try to prove that. By the way, how do you prove this? You would say that you are telling me that BC divides A. Can you translate it in mathematical language? What is the meaning of this statement? This statement means there exists a Q where in the set of integers such that what happens, the number on the right is equal to the number on the left multiplied by Q. Yes, is that understandable for everyone? So if you don't like this symbol, you need to write there exists a Q in the set of integers such that, but this is much more convenient. So everyone agrees with this statement? Yes or no? Okay, now how can I view this problem? I can say that now I am sure that A is equal to BC times Q. But we know that I can write it as B times CQ. By the way, this is important to be able to write these proofs, yes? Yes or no? Now, where this C is coming from, C is an integer, Q is also an integer. If I multiply two integers, the result is a new integer probably. Okay, and then I can give it a name, for example, capital Q. Okay, so be careful about that. This is very important. You can always give a name to a combination, but the important in number theory is that when you want to give it a name, you need to make sure that what you are giving it a name, it is an integer. Is it an integer? Yes. Why? Because C was an integer from the beginning. Q is also an integer because of the definition, and if I multiply two integers, it becomes an integer. And now look, what is happening? It means that A is equal to B times an integer. Yes? Do you agree with this statement? And then what is the consequence of this? What can I conclude from here? The right-hand side is an integer multiple of the left-hand side. So if I want, I can conclude that what? B divides A. Yes? Is that understandable? But I can repeat the proof in a different way. I can start from here again. And what should I write? This time I bring C out and put B and Q together. This is also the same thing. There is no difference between BCQ or CBQ. They are the same. But now, can I call this a new name? Yes, here, because B is an integer, Q is also an integer, so the product is an integer. So I can name it Q, but because I have already used letter Q, so let me change it, for example, to Q prime. By the way, Q prime has nothing to do with derivative, yes? Q prime is just another name. If you want, I can change it. Is it confusing for you if I use prime or not? This prime has nothing to do with derivative, yes? It's just another name. I can call it capital T, for example. Okay, and then the point is that this is an integer. Now look, A is equal to C times Q prime. But what do I know about Q prime? I know that Q prime is an integer. So what is an immediate consequence of this if I want to conclude it? I would say that the number on the right is an integer multiple of the number on the left. So it means C divides A. So this is the proof for why this is true. So if BC divides A, then both of them have to divide A. Yes, is that understandable? Okay, so now let me ask you another question. What happens, what is the consequence of this? For example, if I say A is an integer, and I give you this thing that A divides 1. Okay, so what can you conclude in general? These are the things that I wanted to get used to this symbol. What is the immediate consequence of this? Yes?
Is it that A is 1
Not exactly.
or negative?
Or negative. Yes? So if you know that A belongs to Z, and you know that A divides 1, what can you conclude? You can conclude that A is minus 1 or A is equal to 1. Let me ask you another question. What do you think will happen here? If A divides minus 7, what can I conclude? What do you think I can conclude? A divides minus 7. How many possibilities are there? Yes?
I would say 3.
Yes? I should.
Minus 7 itself.
Yes?
7 and 1. Or 4, okay.
4 and
1
minus
and
1.
minus 1.
Yes. So this means that A is minus plus or minus 1. Yes? Two scenarios. Or plus or minus 7. What is important for me to understand is that when I have a fixed number on the right, this is restrictive. Okay, so for example, what do I mean by that? If I write this here, minus 7 divides A, okay, how many possibilities are there now? So here, you wanted to choose A in a way that minus 7 is divisible by that number. But here you have to choose A in a way that A is divisible by minus 7. Yes?
A is equal to plus or minus 7.
No? Much more than that. Infinitely many choices. Yes? We have infinitely many choices. Plus or minus 7 is probably the smallest one. Yes? But if I want to describe them, what can I say?
Any factor of -7.
Yeah, any multiple of -7 or 7, it doesn't matter, yes? So here it means that any number that is multiple of 7, where k belongs to the set of integers. So how many choices? Infinitely many choices. So this is important. So if you have a fixed number on the right hand side of this relation, then there are a finitely many options. But if you have a fixed number on the left and a variable number on the right, that number on the right should be an integer multiple of on the number on the left, and then that would be infinitely many possibilities. Yes? So another question is that if I have this, assume that this is true, do you think I can conclude that A divides minus B? So what I am doing, let me just multiply both sides. This is a little bit unusual way of doing things. So this is a relation. I am assuming that this is true. I am asking you, is it possible to multiply both sides by a negative sign and still this is true or not? Do you think this becomes true again? Yes or no? Because if you want to do it quickly, b over a is an integer. So minus b over minus a would be the same number. So then yes. What about this one? I just multiply only the right hand side by a negative sign. This is true. Do you think this is also 100% true or not? Yes or no? I should be quick in these things. So that terminology is so b over a in your head, you divide b over a, you see that this is an integer. You want to answer this question, again in your head you divide minus b over a. If this is an integer, this number is negative of that number. If this is an integer, this is also an integer. So if this is true, and this is also true. Or what about this one? Do you think this is also true? Yes or no? That's also true. Yes, because that would be b over minus a, but all these two numbers are the same. Yes? So be careful. These are the rules. These are a lot of rules. If you use them and they are correct, might be I agree with them, but if you just use them, it is not correct. Of course, I will not give you some points. So there are many rules here. So for example, let me ask you another question. If A divides B, and I tell you that M is an integer. For the safe side, let us take that M is not 0. Do you think that I can conclude M times A? Do you think this is true? I just so let me multiply both sides. Because usually we have used to multiplying both sides by some number. So I am telling you this is true, and I am telling you M is an integer which is not equal to 0 for not being worried about those special cases. And I multiply both sides by M. Do you think that this statement is still true? Yes? Because when you say this is true, it means B over A is what? Is an integer. And then MB over MA is exactly B over A. So that is true. So this is true. But do you think that this is true? This is very, very important. Can I multiply one side by M? Can I? Can I multiply? Do you think this is true or false? Let me again tell you how I am thinking. So when you say A divides B in your head, it means this is an integer. Yes or no? But how I can guarantee this? I divide the right hand side MB by the left hand side. Is it guaranteed that under this that this is an integer? Is it guaranteed that this is also an integer? Yes or no? Why? Because another name of this is M multiplied by B over A. And you know that B over A is an integer. I have already given you that M is also an integer. So if I multiply them, it becomes an integer. Yes? So if this is true, be careful. This is a little bit counterintuitive. This you don't have any problems with that because your brain has got used to multiplying both sides by something if you want to multiply it. But here, which is very, very important, hard problems uses this. So you can multiply one side provided that one side is the right hand side. Be careful. Am I allowed to conclude this? Yes? It's clearly not. Yes? Because, for example, 2 divides 6. I multiply this by 10. It becomes 20 divides 6, which is false. If I want, I can multiply both sides. This is always true. But the hard problems usually uses these things that you can multiply only one side, and provided you remember that one side is not the left-hand side. It has to be the right-hand side. Yes?
Another proof for the last example, that A divides M times B, can you also use the one you used earlier that...
Exactly, that's not the proof. If I want to prove, I will do it like what you are saying now.
Okay, so
Yes. The proof of this is this. Let us just prove it as an exercise. So the proof, let me just prove it formally here. A divides B. I want to prove that A divides MB. And of course here I am telling you that M belongs to Z. M is not equal to 0. If I want you to prove it formally, you would say that A divides B means what? Can you translate it for me? You are telling me that A divides B, there is only one conclusion out of it. That is, there exists what? Can you complete it?
There exists Q.
A Q where?
Belongs to the set of integers
Such that?
B is equal to A times Q.
Yes? This is understandable. But now I want to prove this. I need to show that the right-hand side is an integer multiple of the left-hand side. If I can show this, I am done. But this m, which is next to b, motivates me to multiply both sides by m. In equality, I am not allowed to multiply one side, yes? Because this is just your previous knowledge. I have equality. If I want to make it mb, I have to multiply this by m. And if I want to keep this equality right, I have to do the same thing on the right-hand side as well. I cannot choose here. Okay, so let us just do that. I multiply the left-hand side by m. To keep the equality right, I have to do the same thing on the right-hand side as well. Yes? But this interpretation is important. What do I need? I need to have a alone. So I write this in this form. I write a, and I put m and q together. Yes? And now I am telling you where m is coming from. It's given, m is an integer. Where q is coming from, q is also an integer. So if I multiply two integers, the answer is an integer. So I can call it capital Q, but the important thing, I can always call something capital Q, but the important thing is that I was convinced that this capital Q is an integer. So now look, the left-hand side is equal to an integer multiple of a. So what is the consequence of this? It means a divides mb. That is the mathematical proof for this. But that is more or less exactly the same thing. So if you want to understand it immediately, might be this old way is actually very helpful, at least to understand if this is true or false. Yes? So when the lesson ends, 10? You don't know? Yeah, I think it should be 10.
Yeah, it's 10.
Okay, so we have a little bit of time, so let me finalize this at least. We have reached to some point. Okay, so let me ask you one question. If I tell you that a and b are integers, not zero integers, like by the way, we know set theory, so I can write minus 0. So it means that the set of all integers except 0. So, and I tell you that a divides b. Okay? What can I conclude about the absolute value of a and absolute value of b? You know what absolute value is, yes? Absolute value of a positive number is itself. Absolute value of a negative number is negative itself. So absolute value of 2 is 2. Absolute value of minus 2 is again 2. Yes? That is the magnitude of the number, regardless of its size. Regardless of its sign. Okay, which one is bigger in this case? You already know probably, you have an intuition. If I know that a divides b, in other words, if b is divisible by a, and I want to compare the size of absolute value of a and the size of absolute value of b, do you think there is a nice relation between them, or it's random? I mean, can you conclude the absolute values are equal? Can you conclude the absolute value of a is smaller, or the other way around? Or it depends to the situation that you are studying? Yes?
I would guess that a is smaller than or equal to b.
Absolute value of a, yes. So the absolute value of a is less than or equal to absolute value of b. But if you conclude this is in general false. Yes? Why is that? If someone tells me that a divides b, do you think I can immediately conclude a is less than or equal to b? Why not? Because 2 divides minus 4. Do you agree that this is a true statement? 2 divides minus 4. But can I say that 2 is smaller than minus 4? No. So be careful. You are not allowed to conclude this. But you are allowed to conclude that absolute value of A is less than or equal to absolute value of B. Yes? And why is that? The reason is clear, because you are telling me that A divides B, so I can conclude that there exists a Q in Z such that B is equal to AQ. Yes? But here I can say more. I can say that definitely Q is not 0. In general, I don't have any guarantee that Q is not 0, but in this particular case, I am sure that Q is not 0. Why? Because if Q is equal to 0, 0 times A becomes 0 and B becomes 0. But it is emphasized that B is not 0. So here, on the other hand, since B is not 0, Q is not 0 as well. Okay? Now, B is equal to AQ, so it means the absolute value of the left-hand side should also be equal to the absolute value of the right-hand side. If two numbers are equal, the absolute values are also equal. But I don't know how much do you know about absolute value. This can be written as absolute value of this times absolute value of this. Now, can you tell me what is the lowest possible number for this? Q is an integer. On the other hand, Q is not 0. So absolute value of Q starts from what? 1, yes? Because absolute values are 0, plus or minus 1, absolute value becomes 1, plus or minus 2, absolute value becomes 2, etc., etc. But now you know that this is not possible, so the minimum value of absolute value Q is 1. So from here, absolute value of B is equal to the absolute value of A multiplied by a number which starts from 1 or larger. So this means that absolute value of B is greater than or equal to absolute value of A. Yes? Absolute value of B is equal to absolute value of A multiplied by a number larger than 1. So this one is definitely bigger than that. Yes? So you see that this is true. Let me ask you one more question here. What do you think this will happen? This is extremely important. If A divides B, so let me write. A and B are integers. A and B are not 0. And we know that A divides B and B divides A. What is an immediate consequence of that? This is extremely important. So let me just write this. This phrase is important. Yes, very important. I mean, we will use it a lot. Okay, so if I tell you that A divides B and simultaneously B divides A, what is the conclusion? Yes?
They are either equal or the negative
Of each other.
of
Yes,
each other.
that is the consequence. So A, this is extremely important to understand that A is equal to B or A is equal to minus B. Okay, why is that true? We don't need to start everything from scratch now because we have this theorem here. So you are telling me that A divides B. According to that theorem, the absolute value of the left-hand side is less than or equal to the absolute value of the right-hand side. But you are also telling me that B divides A. It means that, again, the absolute value of the left-hand side is less than or equal to the absolute value of the right-hand side. Yes? This one is actually the consequence of what we have shown. Do you agree with this one as well? Okay, but now what is the consequence coming from this? I know that I have two numbers this one is less than or equal to this, and this one is also less than or equal to this, then I can conclude that these two numbers are exactly the same. Yes? And now if two numbers, if the absolute value of two numbers are equal, there are only two possibilities. Either they are exactly equal or they are opposite of each other. So this means that A is equal to B or A is equal to minus B, and that is the proof of that. Okay, what can you conclude here? If A and B belongs to the set of natural numbers, and I tell you that A divides B and B divides A, what can you conclude now? What can I conclude? Yes? B, because the other scenario does not work here. So if I know for some reason, sometimes we are working with positive numbers, in the realm of positive integers, if I have both of them, I can only conclude one of them. A has to be equal to B. Yes? So that is an extremely important property. So I want you to learn. Okay, I will stop here and then we continue our lesson later. So this preliminary lesson is actually might be a little bit boring, but it is very important. If you do not understand this part, then you will have all trouble when we continue. So please review this video later or this lesson, and then we continue later. Okay, thank you very much.